Assalamualaikum and greeting to all panels. My name is Mahmud Nabil Bin Mohamad Hasannuddin from SDE4. Today, I will present my final year project 1. The title for my project is Designing of Thin Electroplating Jig for Copper Bus Bar in Flexible Connected Industry. My presentation contains introduction, literature review, methodology and conclusion. Firstly, I will present the introduction of the project. Electroplating is an electrochemical process which metal deposit on the substance is supplied through the bath chemical containing the metal of interest under the application of direct current voltage across the ionide and cathodite side of the plating cell. G is the most important auxiliary tool for electroplating process. It is tool not only to make sure the plating workpiece connect with the cathode, but also has direct impact on the coating layer, distribution and efficiency. The objective for the project is to propose the suitable jig that make the coating uniformly. Next is to estimate the suitable distance from the cathode, that of the immunization, conductivity, angle and current flow. The third one is to increase the efficiency of the jig. The scope of the project is the study need to carry out within the equipment, solution and process for the electroplating. The analysis for system efficiency based on the current study and the technology. The method that I use in designing the jig for the thin electroplating is using the SolidWorks software and do some calculation. The problem for this project is designing the suitable thin electroplating jig. A few factors must be considered to make sure that no defect occur on the copper bus bar. The problem that will occur are the decolorization, burning, non-uniform thickness and many more. The discoloration problem of the copper layer is to consider to be the effect by the copper oxide lacking of specific static research. The high temperature and not suitable dilation is cause of the burning effect. Non-uniform thickness occur because of the size of cathode is bigger than the anode. The second topic is research on the literature review. I have been doing research on the copper bus bar, copper electroplating, cathode, SolidWorks software and SolidWorks software. Copper bus bar conductor are fundamental part for any current switch bar. A simulation has been made to stimulate the operating temperature of several current carrying copper bus bar conductor ranging in certain bus zone. The production of MATLAB script is able to create the plot that consists operating temperature curve for the static current and ambient temperature. This produces another technique for the switch bar manufacturer to find the bus bar current carrying capacity in the specific enclosure. The technique is used to make sure that the products that have been produced is stable with the issue and has no defects. Next, I will do research on the defect of copper bus bar. There are many defects that will happen if the material and the tool that will be used is not suitable. One of the problem is nucleation, growth of intermetallic and gold cluster. Nucleation and growth median of sequential electroplating of the gold over thick layer has been researched by SCM, EDX and X-ray diffraction technique. The results show that the gold sphere grow in size and combine with each other to shape a larger cluster. The basic understanding of nucleation and growth mechanism is vital in driving the design of plating process to make the gold thin composite for the lead-free soldering based on the solder alloy without utilizing flux. Next is research on the copper electroplating. The process of electroplating must be observed to find the effect on the jig and the products. First is the behavior of the additive. The suppression performance of copper electrodisposition by additive have been measured using the microfluidic device. Powerful suppression and is stopping because of the additive absorption deflection on the plating surface is suspected to be critical for the copper bottom up through silicon via filling. Throughout the electroplating, the provider of additive was interfered by exchanging of the plating solution in the microfluid device, and the activation of additive was monitored clearly. Optical microscope image exposed that manifestation of numerous protrusions after the level product had been interfered. Next is optimization of the copper plating process, which is the impact of the copper absorption parameter, acceleration and leveler concentration and contact current density on the microvia filling encroachment was investigated by utilizing the Taguchi experiment design method. Research also has been made on the electrode. Electrode is very important tool in electroplating, so it needs to find a suitable electrode beam based on the products that need to produce. The study has made to take the fused deposition, the modeling 3D painting to manufacture electrode from the polytech acid or copper composite filament and heating them to the surface fragilization by the copper electroplating pointing at the removing the kinetic barrier. A demonstration has been made on the electrode altered by the optimized electroplating procedure reveal visual to kinetic barrier and produce Faraday reply with the magnitude comparable to the acquired of the conventional metallic carbon based electrode. The last research is on the SolidWorks. In designing the electroplating, a software has been used to illustrate the 3D modeling with which is SolidWorks. SolidWorks is an iterative feeder as CAD system. It's mainly on the parametric object-oriented methodology. The SolidWorks feeder is SolidWorks simulation. The study has been made to interpret the effect of quality SolidWorks simulation grid on the precision of computation of valves of the hydraulic distributor of the Amcodo 208 loader. The results show that thickening of the grid improved it. The next topic is methodology, which is a method that I use to design the G and simulate the electroplating process. The method that I use is getting 3D model of the G, meshing using analysis and ANSYS, governing equation, setting the material properties and analyze the process. For creating the 3D modeling of G, is need to create a stable G that can hold bus bar properly to get the required shape in the workpiece. Tool should be designed properly. The shape of the tool affect the critical parameter of machining. Next method is meshing. Using ANSYS, which model is mesh using ANSYS mesh model in the ANSYS commercial software. Patch in the independent meshing method is adopted to meshing present geometry model. Patch is independent method used to top-down approach, which means it create a volume mesh and extract surface mesh from boundaries. Third method is governing equation. Governing equation are two types, which first one is computing fluid dynamic model equation and some user-defined equation based for modeling. Computing fluid dynamic model is used to gradient-based hypothesis for making relationship between the final stress to the mean velocity gradient and the turbulent velocity sum. Some user-defined equations are used to finding out the velocity, the desired parameter in the volume flow rate range for the electrolyte. Last method is analyze the process. Analyze using CFX is much simpler than Fluence, as the MHD option can be easily activated for the simulation. To start with the analysis, the problem need to be categorized in the either steady state or transient state. From our research, I can conclude that suitable material for the G is copper, so it will optimize the process. The additive is very important to improve the quality of the product that has been produced. Before doing analysis, the material properties of all the three material of the tool, workpiece, and the brine are studied and presented. G that is been designed must fulfill all the requirements. That's all for me. Thank you for lending your ears. That's all my presentation. Thank you.